In this video, I'll be demonstrating how Veritas Alta Enterprise Resiliency provides high availability for Oracle in the public cloud. Let's first take a quick high-level view of the components deployed in the AWS public cloud. As shown in the illustration, there is a VPC created in North Virginia region, which has 3 availability zones, route tables, and DNS. 2 EC2 instances with EBS volumes are created within different availability zones. Veritas Alta Enterprise Resiliency is installed in these 2 instances to form a cluster. A coordination point server is deployed on the EC2 instance in a different availability zone to maintain data integrity within the cluster for split-brain scenarios. The Veritas Alta Enterprise Resiliency Operation Manager, also known as VIAM, is deployed on another EC2 instance to manage storage and high availability of the resources within the cluster. Veritas Alta Enterprise Resiliency also provides storage features such as flexible storage sharing to allow for parallel access to the storage volumes, Volume Manager to manage physical disks with logical data volumes, and Cluster File System to support parallel access to data by multiple compute instances. Veritas Alta Enterprise Resiliency Fast Failover Solution consists of an Oracle Database single instance installed and configured in both systems in active-passive mode. The clustered file system volumes which hold the Oracle data is concurrently mounted on each of the instances such that if the active instance fails, the Oracle database is restarted on the passive node quickly. Now let's see Veritas Alta Enterprise Resiliency for Oracle in action. Shown here are 3 windows: Veritas Alta Enterprise Resiliency Web Interface VIAM, the AWS console, and Oracle SQL Developer to run operations on the database. From the AWS console, you can see EC2 instances in different availability zones which make up the Veritas Alta Enterprise Resiliency 2-node cluster. An EC2 instance acting as a coordination point server in another availability zone, and an EC2 instance hosting VIAM. Each of the nodes in the cluster has 2 additional volumes attached for the data. Navigating to the VIAM window, we can see that the EC2 instances forming the clusters have been registered. This centralized management console provides management, monitoring, and reporting of the system's storage resources and availability of the cluster. Expanding the system resources, a disk group was created and enabled for flexible storage sharing. This disk group is comprised of the EBS volumes in each of the EC2 instances. From the disk groups, volumes and cluster file systems are created and are accessible by both nodes in the cluster. To place Oracle under control of Veritas Alta Enterprise Resiliency for availability, service groups are created in the Availability tab to define how the resources within the cluster are to be started and stopped, as well as if the resources are in active-active or active-passive mode. Looking at the Data SG service group, the volumes for Oracle are active and mounted on both nodes as indicated by the blue boxes underneath each node name. The parallel mount allows for a fast failover to passive node when the active node fails. For Oracle service group, it is in failover mode such that the main Oracle resources are only active on one of the nodes indicated by the blue boxes and passive on the other node as indicated by the gray boxes. Thus, only one node will process Oracle requests. Veritas Alta Enterprise Resiliency has specialized agents for Oracle, storage, network interfaces, and cloud agents to monitor and manage the resources within the service groups. From the service group status of the cluster view, the Oracle services are running on node AJ Azora 6 and passive on node AJ Azora 5. As previously mentioned, the Oracle data is mounted on both nodes defined in the Data SG service group. Let's now simulate a node failure by shutting down node AJ Azora 6 via the AWS console. But first, let's look at the DNS entries for Oracle. The virtual IP of AJ Azora 6 is currently assigned to Oracle DNS name. Once the AJ Azora 6 is shut down, we will observe that this virtual IP will be changed to the virtual IP of AJ Azora 5. From the Oracle SQL Developer application, let's verify that the Oracle database is up and running. Now I will shut down AJ Azora 6 via the AWS console. Once Veritas Alta Enterprise Resiliency detects that the node AJ Azora 6 is down, it will begin to mark some services as faulted and start to fail over to the other node, AJ Zora 5. Testing the connection again via Oracle SQL Developer, we can observe that the database is visibly down. In Viam, we can start to see that the services are coming online on node AJ Zora 5 and that node AJ Zora 6 is in unknown state indicated by the circled question marks next to the boxes. Note that since the Oracle data is mounted on both nodes defined in the Data SG service group, this service will not need to be brought up. This concurrent mount eliminates the storage operations required to start the Oracle database and provides a fast failover of services onto a node AJ Zora 5. Now that all the services are running, we can refresh the DNS and see that the DNS entry for Oracle has been updated to the virtual IP of AJ Zora 5. From the Oracle SQL Developer, we are now able to connect to the Oracle database and run a simple query to confirm that Oracle is indeed running and has been mounted. As shown from this demo, Veritas Alta Enterprise Resiliency adds significant value for Oracle single-instance databases by providing high availability similar to RAC with less complexity, lower cost, and flexibility to run in any public cloud. Thank you for watching.